Okay. Sorry. Okay. 2 seconds. All right. So we have an energy budget, right? Okay, we have an energy, listen, y'all with me? We have an energy budget. So keep that in mind. And we are tracking, like NASA is busy tracking how much of our, sorry if you're watching, I started late, but you didn't really miss a whole lot, just a slide. Anyway, NASA tracks it because it's important for us to understand how much is coming in and how much is going out. So what do we call, these are conventional energy sources, what do we call materials that are consumed to produce energy? Jack?
Fuels.
Yay! Okay, fuels. All right. So this is what we use when we're going to produce energy. And what are the fuels that are derived from living things like hydrocarbons, which are molecules with hydrogen carbon bonds only? All right. So what are these called? Yusuf.
Biomass.
Okay. So these are fuels that come from living things. So what's another way to describe something that contains hydrocarbons that's a living thing? Drew? That's the one I want. They're organic things. All right. So these are organic fuels. So somebody give me an example of one that's, let's see, Alex.
There's coal, there's natural.
Wait, just one. Okay. Holy's saying, all right. What do you say?
Wood.
Wood is a great example.
Fecal matter.
Fecal matter, yep. Gross, but yep. All right. How about you, Eunice? What do you think?
Is it a bark?
Yeah, bark can be burned. Sure. How about you?
Marijuana.
Yep. Yeah, but that's not an appropriate answer. Nor do we use it as a fuel. Hopefully we do not. Oops, sorry. So, Bailey.
Natural gas.
Okay, so
One that every
these, okay, so listen. So this is a little different. If you're gonna label something that's formed over geologic time by compression and incomplete decomposition of organic matter, what do we call this type of thing? Liam?
possible.
Okay, so fossil fuels. So technically, coal and natural gas, even though they are formed from organic organisms, they're considered fossil fuels because they take forever to form, and and they form under all this compression. Yes, Alex.
Another organic fuel that everybody's missed is the food you eat.
Yeah, that's true for you. That's absolutely your fuel. 100% your fuel. All right.
There's peat.
Peat. Okay, peat's a good example too. Now, peat's one of those ones that takes a long time though under compression. So what?
Field crops.
Field crops are a good example. So yes, we actually have like a well, we'll talk about it, but there's a gasohol and an ethanol and things like that. So here's a good example. You got some oil here and coal and other coal, and then there's this. Now, this is on a bucket list for me. So this is super cool. This guy got a great video of this hike. This is in New York, and I really would like to do this one day. So check this out because it's way awesome. Way awesome. Yeah.
What's this about?
Watch, he'll tell you. It's really cool. Super cool. Really neat.
What's going on, everyone? What do you want to do this weekend? Where do you want to go? Someplace warm. A place where the beer flows like wine. Well, I'm not sure there's a place anymore where the beer flows like wine. Earlier this weekend, came across and he ended the trail with a waterfall, but not just any waterfall. Underneath the waterfall is fire. Apparently, that fire is eternal. We're not even reading it. What is out here? I've got 2 hours to show here on Saturday. So we're gonna hop in my car and drive out to Orchard Park, New York, see what this thing is all about.
We have arrived at the trailhead located in Chestnut Ridge Park. There are a lot of cars. Odds are good that there's just going to be a lot of people here. Here we go.
All right, now you're a couple hundred feet into the trail here, and there is a ton of place. So I'm gonna stop here and put on my microscope before I keep going. I actually ran into a couple people who said they fell a couple times on the way down. So really glad I brought these. Almost right off the bat, the trail leads you into this beautiful little forest here. And the trail itself is marked really clearly with little flames of the trees, so it's really no problem at all to navigate.
That ice though. Ooh.
Right, so we've made it down into the ravine. Stopping the ice is very, very easy hike. Distance one way is just over a half mile. So if you're coming here just to see the falls, we can get this done round trip in just over a mile, probably about an hour, hour and a half if you're taking your time. And once you're down here, you start to smell something. It smells a little bit like rotten eggs. And that rotten egg smell is from methane gas seeping through the shale. So millions of years ago, plants and animals died and were covered over in sediment. And the hundreds of millions of years of pressure turns them into methane. And if you find a hole in the shale, some of that gas will escape. And if it's big enough, you can light it. And that's what we're about to see, a flame underneath the waterfall. It's called the Eternal Flame Falls, but the flame sometimes goes out. So people will come by with lighters and relight it. It's not quite eternal.
The eternal flame falls when we want it.
Yeah.
Run out?
Nope, that hasn't so far.
It'll eventually run out, probably.
Yeah, but look at that. That's crazy.
All right, we have made it to the Eternal Flame Fall. The national right behind me is where the flame is. So we're gonna try to get a few photos. I thought it'd be cool with the contrast of the flame and the ice and the water. Problem is, the flame is kind of in a little cave. And the water that's flowing right now is on the far side of what would be the composition. So we'll see what we get here.
This guy's a photographer, so he tells you what he's using. It's neat. Now, if you go here in the summer when it's not frozen, the water goes over the little cave with the
There you
flame,
have it. That's
like
photos here.
over it.
It was interesting trying to get the flame to show up next to the ice and the water. You kind of lose the flame if you zoom out to get most of the falls, but still a really cool thing to see. And I mean, everything that you see right here behind me is totally 100% natural. As far as the gas coming out of the earth, that is all an earth process. None of this is manufactured by man. However, the flame will go out every once in a while. So if you're planning on visiting this fall, you might want to bring a lighter with you just in case it's not lit when you come down here. As far as the hike goes, I was saying this a little bit earlier, very accessible hike, saw a lot of kids, a lot of pets. We're here.
Oh, doggies. Yeah, Aussies too.
Beautiful.
So that's a great question. I imagine, you know, when you smell that, you know, people have known for a long time what natural gas smells like and have used it. This is not the only place in the world, obviously, where you've got natural gas coming out of the ground and it can be lit. There are places with flames like that. This one's just really particularly interesting because the waterfall goes over it. And like I said, like if you come in the summer when it doesn't, not covered in ice, that fall goes right over the cave and you look through the falling water at the flame. And you have to like go kind of under the waterfall to get in the same vicinity of it. Uh-huh.
And not quite methane, but there is one town in like Kentucky, Tennessee area where there's a coal mine that is on fire under the town.
Oh, fabulous.
Yeah, and it has been on fire for like 50 to 100 years.
Oh, that's great. Yeah. All
The
right.
coal mine is still on fire and will be for a very long time.
That would make me anxious, I'm
It was
afraid.
put out when it originally,
Yeah, yeah. Yes, Yusuf. Yes, of course. You don't have to ask, you just go. Mhm. Yep. So anyway, there are places like this that you can visit. And like, this is in the US. I mean, if you wanted to drive, you could drive. New York's a good distance, but it's not the end of the world. So it's the way. So we have alternative energy sources to our fossil fuels. So solar energy has a couple of different forms. So there's a type of solar heating that involves windows, walls, and floors that are designed to collect, store, and distribute solar energy. What's this kind called? You know, Liam? Yeah, here we go. So this is our, hello. Do you click? Oh, boy. That's our passive solar energy. All right, so this is when you've got like your windows, your walls, your floors designed to collect the heat. So certain houses, especially in cool areas.
IPA, Bryan Point, solar energy in the
Space.
second paragraph, there's no space between solar and energy.
Oh, look at that. You caught another one. Okay, that's 2 today. Very good. All right, so, do you have a question? Yeah.
Wanna give this
What,
money?
oh, you want to do the next one? Okay, so the next kind of heating uses mechanical and electrical equipment to enhance the conversion of solar and energy and electric power. What, okay, let me do Milo. He hasn't gone yet. Yeah. There you go, active. All right, so an interesting example of kind of a combination of the two. My in-laws have a pool. All right, and to keep their pool heated on the roof of their house, they have these big rectangles. They're big black rectangles. And what they have is they have a tube that runs through them, and their pool pump pumps the water up and onto the roof. And as the water runs through all these little tubes that are in this big black casing, the sun comes down, it hits it, makes it really hot. And then that water is gravity pulls it back down into the pool. So the water is warmed that way. Bailey.
We used to have something like that for our pool in our backyard.
Oh, yeah? Yeah, you did? What'd you?
Yeah, it was just like a thing, it was like a thing of plywood with some,
Hmm?
like 2x2s, I think, on the top and the bottom, had some foam put in it, then we'd have tubes that would run across.
Mm-hmm.
Water would get pumped through, and then back into the circulation.
Yeah.
And I'd go into the water.
So they have a big garden situation in their backyard. Like they have all kinds of stuff growing. It's a complex situation. So yeah, so
We don't
this
have
is
to
one
do
way to heat it.
anymore,
Yeah. Mm-hmm. Bailey?
It's for the thing or?
Oh, yeah, you can answer the next one. So what is it that converts solar energy to electric energy? There you go. Photovoltaic cells. Yeah, solar panels are composed of. Yeah. So that's what they're composed of is photovoltaic cells.
Yeah.
So they look kind of like this. And this is how they convert the energy from solar to electrical. Alex.
If I remember correctly, they work by having photons knock electrons from
Yeah.
one section to another, and then in order for it to get back, it goes through, and that creates electricity.
Yeah, it's kind of like, yeah, they're bouncing the charges basically back and forth. Yeah,
You get
that's
a photon to knock some electrons off of orbit, and then reset itself and creates an electric
Mhm.
charge.
so photovoltaic cells are these, yeah, this definitely a death ray. So
Everyone's KFC.
people that are very, very pro solar energy have had this argument tossed in their faces a couple times because this was pretty frightening.
That's
Solar energy plants are getting
fried
faster,
chicken.
killing birds. These facilities in the desert are supposed to be the future of clean energy, but now federal wildlife officials want to pause their expansion until they get a handle on the growing number of bird deaths.
Solar fried chicken.
It looks like a mirage in the middle of the Mojave Desert, but it's actually 170,000 sets of mirrors the size of garage doors called heliostats.
Don't know why it's so blurry.
How much power do you get from each one?
So this project will
Wait, hold
fuel
on.
140,000 California homes. So effectively, one heliostat can power one California home.
So Tom Doyle is the CEO of NRG, the company behind this $2.2 billion solar project. It's now under fire because the heat it produces, up to 900 degrees, is charring the feathers of birds flying through, often causing them to crash and die. Workers on site call them streamers because of the smoke plume created when the birds ignite in midair. Avian mortality at 3 Southern California facilities, federal investigators found that these solar farms may act as a mega trap, attracting insects which in turn attract insect-eating birds, which are then incapacitated. More than 500 birds have died at one plant, and 1,000 more are expected to die every year at another.
They found mortalities at all 3 solar technologies, and they found a wide range of bird species being killed.
Birds often have a hard time navigating traditional barriers, including airplanes and windows. Wind farms kill more than 100,000 birds each year, but solar farms are a new obstacle. One solar company spent $22 million to protect and relocate hundreds of rare desert tortoises and is now worried about the birds. In a statement, the company said, "We are evaluating the use of humane avian deterrent systems similar to those employed by airports." Other solar fields are planned for the California desert, including one near Joshua Tree National Park, which is on a well-known flight path for migrating birds, eagles, and falcons.
So right now, there is no solution, but these solar plants plan to experiment with everything from light, sound, and even drones to try to scare the birds away so they can keep on flying.
900 degrees.
900 degrees.
Wow, all right, thank you.
Wow, oh, that's about. Everyone's awake, right? There we go. It's terrible. I don't know how I did that. All right, so do you know what they do at airports? They do a couple different things at airports. Does anybody know what any of the airport solutions are to keep birds? Drew?
Hawks.
Hawks. How do they use hawks at airports to keep birds out of the way?
Hawks, and then they throw them out. And then
Yep.
The birds don't want to get killed by the hawks.
They do. There are falconers. They're professional falconers, bird handlers, right? Who will go out there to the airport, and their job is every so often at regular intervals to send their hawk out, and he'll fly around and he'll come back, and the birds are like, shoot, we're not going over there because that thing will eat us. So they come back. Does anybody know any others? Yeah.
No, I just want to say, what do you do for a living? I throw birds at airplanes.
Throw birds at airplanes. What do you think? Yeah, they do. They use loud noises. They use like there are speakers that send out, sounds we don't hear, but the birds do hear. There are also huge, I think right now Hartsfield has like a huge it's like an air cannon. And that it makes this boom. So the reason birds are so dangerous at airports is because if they can you explain it?
They get sucked into the engine.
Yeah, they get sucked into the engine. Anybody know the story of the Miracle on the Hudson with Sully Sullenberger, the guy who like landed the plane on the Hudson River? Do you remember that? Let me see that movie. Tom Hanks was Sully Sullenberger. Yeah, he had birds strike his engines. Yeah, yep.
See, these are evil.
Birds struck his engines and his plane was not able to fly anymore. So these big solar farms, as they're called in the desert, do have a drawback. While that guy pointed out that each one of those like garage door size cells can power a California home, that's great. But when you got birds streaming, as they called it, from the sky, leaving a trail of smoke behind them as they've ignited in midair, that's not a fabulous thing. And some of them, because of the way their mirrors are tilted, yeah, there you go. It like concentrates the sunbeams. So it is like a death ray. I mean, for real.
That's how they produce electricity.
All right, so some other sources. All right, Yusuf, what's this one? Converts energy of free or falling water to generate electricity. Hydroelectric. Okay, where's our hydroelectric?
I've got
Okay. James. Yeah, which dam? Yeah, our Beaver Dam, right up the river, straight up the river. Beaver Dam is hydroelectric. Anybody ever gone and watched it open? There's a park there on this side, the southern side of the dam, and you can go and you can watch the water come out at certain times. You can stand on a bridge and watch it come rushing out. Now, I've explained this before, but to refresh your memory, the reason why the Chattahoochee right here where we are is particularly dangerous to be in is because where is that water from the lake coming from? What part of the lake is it coming from, Bailey? The very bottom of the lake. So it's cold. So cold water is going to be more dense. Well, yeah, that too. But it's going to be more dense than all the sun-drenched water on the top of the river. So that water comes out and yeah.
It goes under, it goes really fast, and anything that gets caught gets dragged down and pulled along and suffocated.
Yes, so it goes very, very thick fast because it has the entire lake pushing it out. That's a lot of pressure.
Squeezed out.
Yeah, it's being squeezed out. It's being shoved out really, really hard from all that force behind it, and then it goes right under, and you can't see it.
Say I want to get rid of someone.
Yeah.
First name, don't try and use it to make a. Don't try.
Piper's asking a scary question. Go ahead.
To make it seem like
They'd be able to
they
check, you need to put water in the lungs.
accidentally fell
Yeah,
into the river.
yeah,
They would still be alive, yeah, when you push them.
when you push them
You
in.
have to make sure of that, because they can actually check for water in the lungs.
Yeah.
Unless you actually-
So they're actually, how do you do that? So you know what you've heard, right?
Jump off one of the bridges.
Friends will help you move, but real friends will help you move bodies. You heard that before? So yeah, okay. So we got, okay, hold on. Let's refocus. I know we got our birds over here. My mourning doves are, yeah, they get a little aggressive. So yes, so the water in the river will flow more quickly underneath than on the surface, and you cannot see that current. All right, so what do we call energy from the ocean? Who hasn't gone yet? Chloe? There you go. So we do have waves, which cause, yeah, you can cause tidal energy or you can have wave motion energy. So you can convert energy from one kind to another, right? Because remember, our law of conservation of energy is that it doesn't go away. It's just converted from one type or one kind to another. So you can take the kinetic energy from the ocean, just like you can take kinetic energy from windmills, and convert it to electric energy, which is what we're going to use in our homes. Yes.
Also, mass is made out of energy, at least according to Einstein.
Mm-hmm. All right.
So
Yusuf?
think- Wait, are you thinking what I'm thinking?
What were you gonna? Nothing? Okay,
Mass is-
so now this here is our lake. And this is some historical footage, Alex. This is some historical footage of our lake. Now, you've probably heard stories about Lake Lanier. Oh, it's haunted. Oh, people say it's haunted, right?
Yeah.
And it is true, there are towns underneath. The primary, does anybody know the name of the primary town that was flooded to create Lake Lanier, like completely flooded? So it was called Oscarville. And the thing about Oscarville was it was predominantly an African-American town. They were people who had been shoved out of Forsyth County in the 1910s, 1920s, and had been pushed west. And a lot of them gathered up together in Oscarville, and that's where they lived. And that was, I guess, what the government considered the most convenient and easy group of people to move out of the way. And they were moved out of the way. There were other areas and other parts of other towns that were also flooded, but Oscarville was entirely gone. They did move the cemeteries. There's one off of, it's called Beaver Ruin, not the big Beaver Ruin Road. Beaver Ruin, it's up off of, I think, Pilgrim Mill. And there are a lot of moved graves there into that cemetery. And they took down most of the buildings, but there are things like this racetrack underneath. Yes. Huh? Oh, there's some Band-Aids under the sink in the bathroom. You can go wash it and throw a Band-Aid on. Also, you could ask Alex to pass you tissue if that helps. All right, so here's some historical footage of our dam and our.
11 people have died in drowning or boating accidents on Lake Lanier this year, including a father and son. Charged with responding to all those calls are divers with the local fire department.
11 Alive Cable and Rod shows you what they deal with under the surface of Lake Lanier. It's dangerous and deadly environment.
Clear and calm on the surface, Lake Lanier is anything but.
You can get yourself in trouble really quickly.
Lanier was built in the 1950s to provide drinking water and hydroelectric power for Atlanta. Recreation was an afterthought.
As they were building the lake, they raised the water level up to a certain point, well below what we know of today as full pool, and then stopped filling the water.
From there, construction crews floated on the lake, cutting off the trees about halfway.
So today, those stumps are still there, and they're tall because this was forest land and farmland.
Also beneath the surface, old homes, barns, even a racetrack, which famously surfaced during the 2007 drought. You could see the tops of the stands, a haunted memory, waiting for spectators to show up for the next race. It's all good now, but when the next drought comes.
When that does, everyone needs to use extreme caution on the lake.
The Forsyth and Whole County dive teams respond to every rescue and recovery call.
Generally, within the first hour, we're in what we call rescue mode. We're hoping that we can rescue someone.
I don't want to lose a diver.
Divers deal with frigid temperatures, near zero visibility, and all of those underwater hazards.
The bridges are like the trash bin for anyone traveling down the roads. They blew the old bridges in place. So you have concrete, rebar.
The divers work in teams, one person in the water and the other on the shore. They're tethered together by a rope and communicate by tugs on the rope. divers say they never know what they're going to find.
It's bad enough that you got a loss of life, but you see their grieving family. And that's really why we do this. I couldn't imagine as a father, as a brother, you know, as a son, to see one of my loved ones disappear and have to go by this lake every day and just wonder. That, I wouldn't wish that on anyone.
That is a tough thought to deal with. So the biggest takeaway from our day with the dive teams, always wear a life jacket, even if you are an amazing swimmer.
Yeah, that's right. And there are so many hazards and deep drop-offs. You never know what's beneath that surface.
So this is why I always tell people, if you're in Lake Lanier, you really should have a life jacket on. Even if you, like I said, even if you swim super well, it's just smart. Yeah, there's monkeys. You can see them.
A lot of people die.
Okay, so hold up, listen. So here's the thing with our lake. There are all kinds of hazards, things that will snag you. That's why people that very often like go in that lake and they're just swimming around and then they go under and they don't come back up. The same thing happens here on the river. On the river, you go under, you might come up in Forsyth, I mean, not in Forsyth, in Fulton County, or Gwinnett if you're on the other bank. Yeah. What you can say?
So basically, there were houses and people filled water.
Yes, there were houses and they told everybody to leave and then they flooded it.
I'm kind of impressed everything's not broke, just gone, washed.
Yeah, some of it, a lot of it is, but the visibility in the lake is terrible because of all those things, right? So as those things disintegrate, they don't disappear, right? They just turn to mush, the things that are down there, and then that mush gets spread out everywhere. Apparently it's extremely difficult to scuba dive in that lake. Yeah, Caitlin.
What kind of weirdo?
Okay, what kind of weirdo monkeys are these? All right. So here's an example of thermal energy at work. So if you've got a geothermal hot spring, we have a hot spring in this state. Where is it? Chloe, do you know?
That's the muff boss.
Yes, near FDR's old house. Yep. Does anybody know what it's called? The whole town. Do you know, Jack?
I do know.
You're thinking?
No.
James?
Isn't that where the
Warm Springs, Georgia. Okay.
No, the.
Yes, I think it was.
The
Mhm.
sensational double homicide.
Yeah. That came up. Do you remember when we talked about geothermal energy way back when? You guys researched Warm Springs. There we are. Little White House. Yep. Yusuf. Yes, there's okay, that's where these guys are. So there are, certain places have a lot of hot springs. Actually, I have a friend from college who was on a trip last week. And I don't know where she was, but she was in a hot spring somewhere and she was getting all this video of her and all these other people just chilling in this big old hot spring. She does like production management stuff for bands. So she's always on a tour. She looked like she was having a blast. Yeah.
Can it be considered chilling if you're in the hot spring?
This is true. So,
I read in a book that like in the hot spring there's snow monkeys.
yeah, that's what these are. So we're gonna watch these guys for a minute. This is what you call life goals, like hashtag life goals right here, like for real. I can't read. So macaques, that's what they are. Look at the baby hanging on. I mean, check it out. Yeah, except for those two who are fighting over the same spot. Now at night, these guys leave the water and they go up into the trees And they all cuddle together there. And if you are not in a good spot in the social hierarchy, they will kick you out of the little bundle of monkeys that are staying warm. These macaques will like get in a little group and they'll all be warm. They're all snug and warm together. And there's the one guy that everybody's mad at, and they just kick him out of the tree and kick him out of the tree because that's animal hierarchy for you. So yeah, life goals are to be a macaque in a hot spring. Yep. All right, so let's talk about some alternative energy resources. So what would go here? Produced energy from naturally occurring heat, steam, and hot water. What kind of energy is this? Let's see, who hasn't answered yet? Parker, what's this called? Do you know? Naturally occurring heat from steam and hot water. What's your favorite color, Parker?
Blue.
Okay, there we go. All right, I'll take Piper. Okay, we're looking, there we go. So we have our geothermal. And hey, we're gonna put these pictures in. Ta-da. All right, so guys, volume check. All right, so we have our geothermal energy. And that's where you've got your warm water or your steam or your just warmth from the earth that's used to heat. Now it can be used just to heat a home, for example, or it can be used for generating electricity. Because like I said, you can convert one kind of energy into another, right? It just doesn't disappear, it's converted. All right, so what do we call this stuff with the windmills and the turbines that convert wind energy to power? La 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 la. Liam. Yeah, that's such a hard one, y'all. Wind energy. All right, so look at where these windmills are. Can you tell where they are? That's not a field.
That's the ocean.
That's the water. Yep, they're in the ocean. They will put them out there. Yep. So they will put them in deserts. They'll put them in any kind of field. Y'all. Yo, focus, refocus. Let's refocus. Okay. So yes, they will put them anywhere where there's good wind, and there's certainly good wind out on the ocean. So they will stick them right there. So what's this one? This is produced by nuclear fission, which is the process of splitting a heavy nucleus with a mass greater than 200 into smaller nuclei. Jack?
Nuclear energy?
This is our nuclear, whoop, hold on. This is our nuclear energy. Stop doing that. There you go. All right, so this is what it looks like, y'all, if you were to actually look at a nuclear power plant. So you've got all this water vapor that comes out, and you've seen this probably if you've driven past them. Like there's some just north of Savannah in South Carolina along the coast there, and there's some kind of in the northwestern corner of Georgia too. We have some there. But this isn't steam or this isn't smoke or pollution. It's just water vapor. It's like steam, right? And it's coming out because this is used to cool. So they have a containment building and all this business. Now, do you remember we talked about a place way back at the beginning of the year where there was a massive disaster, nuclear disaster. Hang on, I was asking. Milo, yeah, Chernobyl, yeah. So Chernobyl was a big mess, and it still is, right? They've poured a huge concrete, they call it a sarcophagus, over where the reactor was, right?
Over the elephant's foot.
Yeah.
And another disaster spot or close to disaster was 3 Mile Island.
That's another one. Yep.
Up in New York, I believe.
And there was one Fuji the one in Japan, there was a huge like a tsunami that came through, and then that caused issues. Fukushima, that caused issues with the caused issues with the nuclear power plant up there. So do what? Nagasaki. Yeah, the Hiroshima and Nagasaki are a little different, but yes, Fukushima. All right, so what do we call plant-based alcohol? All righty, go for it, Piper.
Wait, alcohol, that's mine.
Okay, Caitlin. Okay, yeah, so ethanol, which is a biogas. So here's what we got. So ethanol is plant-based alcohol. Now, when you make alcohol for drinking, distilled spirits, vodka, rum, whatever, what you're trying to get to drink is ethanol. Part of the process can produce methanol, which can kill you. So, Parker, so you want to make sure, why don't you sit in one of the chairs where you don't have to have your back to me the whole time? Like turn your chair or sit on the other side. There you go. So you have to have a process for not listen, for not contaminating your distilled spirit and making methanol, because that is so totally not what you want. So, ethanol is what you're making when you're making plant-based alcohol. And so your distilled spirits, like your rum, does anybody know what plant that's made from? You know?
Sugarcane.
Sugarcane, right. Okay, how about vodka? Does anybody know what that's made from, James? Yeah, potatoes. Okay, so it tends to be kind of, and rum comes from like the Caribbean usually,
Yep.
and then vodka comes from where? Like Russia? Okay, so you know what they're using? Whatever grows there well.
Whatever you got, you can make beer out of.
And there's gin. Do you know what gin comes from? Does anybody know what that comes from? Gin comes from like conifer, like juniper type stuff, and it smells like a pine tree. It's
Mead comes from honey, if I remember correctly.
Mead involves honey. Yes. Okay.
And
So what happens with these biofuels is ethanol here, which can burn. Obviously, you can burn ethanol. You can burn alcohol. So you take a plant-based alcohol that you've created, and basically you make it very, very, very strong. So this is not something that you could drink, because if it's 100% ethanol, that would not be okay for humans. That would be bad. But it's obviously also a fuel. So if you were in a bad situation and you needed to have a little heat source in your house because the power had been off and the gas was off or whatever, and you had a bottle of liquor somewhere, you could burn some of it. I was about to say Molotov cocktails. What are those? How's that work? Wait a minute, Piper started it, you know? No? Jack, do you know? Yeah.
I know how to make them.
Do we know? Let me ask you this first. Do we know what the name is, where it came from? Drew, do you know? Russia, but do you know, Bailey? Yeah, do you know why it's called a Molotov cocktail?
I think I've got it.
Get there. You know?
I think it's a specific brand of booze.
No, but that's a great guess. All right, Drew, one more guess.
Cocktail is you take like a piece, you take a bottle of alcohol.
No, what's the name?
Yeah, hang on.
And you
Hang on.
stick a cloth inside of it.
Yeah.
And light the cloth on fire, and then you throw it.
And you
outside.
throw it and it explodes because the ethanol is a fuel. Do you know who Molotov was? Okay. Molotov was part of Lenin's crew, I believe. So he was like one of the communist Bolshevik, I think, right-hand man kind of deal. So that's what that has to deal with.
So like the guy who like hung a bunch of people, that was known as like his necktie, that's like that guy.
That guy. Same idea. Okay. So all of this stuff about liquor, to go back to the point, that ethanol is, and hopefully you remember this, that ethanol is plant-based. And ethanol is the stuff that you can drink, but you don't want to drink it if it's like super high. Now, what do we get that's made from vegetable oil, animal fat, restaurant grease? What do we get?
Biodiesel.
Okay, biodiesel, that's right. And it's typically 20% biofuel, 80% petroleum diesel. Anybody ever helped pump gas into a diesel vehicle before? Anybody ever helped pump gas into a regular running? Yeah, okay. So if you get a little gas on your hands when you're pumping gas, it's almost immediately gone, right? It just kind of evaporates off. There's maybe a little residue left, but diesel is like slime. Like if you get it on you, it's oily, it's greasy. I had to drive a diesel vehicle for work once, and it was bizarre because I filled it up and I'd be like, what? So yeah, so we can make biodiesel using these leftover fats from things like restaurant grease. If you own a restaurant, oh yeah, look at all my doves. If you own a restaurant, you have to have what's called a grease trap. And that's where all of your grease from frying and whatever goes. And Cole knows about the grease trap. Okay, wait, come over here. Cole works at a restaurant. Cole works up at the collection. It used to be called Grub. Now it's called Hop Dotty. Okay, what happened with the grease trap?
We have this big like 5-gallon bucket that we had to take out there because you can't put it on a drain or even in a trash can, so you have to take it out there. And it had been sitting in the back of the restaurant for a while, so the top half of the grease that was in there had solidified, and it was basically just this chunk of grease And I went out there with my coworker and we were pouring it out. We opened it up and there's like a main door where you can open the whole thing, and there's a smaller door with all these little grates. So I didn't realize there was a main door originally. So I opened up the one with the grates and I go to pour it. And of course, this big chunk just falls on top of the grates, and then all the liquid grease that's still in there pours out and goes out. And then I'm like pushing my whole weight on top of it. It's not breaking apart because it's like a hockey puck, but like, you know, this freaking big. And she's freaking out, and I'm like trying to close the lid on it. It's not working. I'm like, okay, I already got gloves on. So like, I just pick up this chunk of grease. I'm like, I open the main door, I'm gonna toss it in there. And she opens it up and toss it in there. And then I'm like, all right, we're good to go. And I look at her and she goes,
I got it in my mouth.
the grease that's already in there splashed up, and she got a lid on her mouth, and she was not happy with me.
That's disgusting. Thank you for sharing. So, yeah. So Dottie, if they wanted, could have their grease traps drained and then shipped somewhere where it's made into biofuel. And this is another one of those, let's try and see if this works things. And yes, it can work, but we do not have this on a grand scale. So not only do we have problems with our solar panels and birds, but now we got wind. I'm telling you.
Wind energy is a big winner in Texas. It's helped lower the cost of your electricity. It's pumped billions into rural economies, and it's dramatically cut carbon dioxide emissions. But some of you are concerned that wind turbines are killing birds.
That's fast.
One message comes from Dale. He writes, I've heard wind turbines kill a staggering number of birds. President Trump also said this. Why is it okay for these windmills to destroy the bird population? And that's what they're doing. So, are wind turbines killing a staggering number of birds? For answers, I'm looking at published research, government information, and interviewing Dr. Scott Law. It sounds like you are the guy when it comes to talking about bird death. He's a professor of applied ecology at Oklahoma State.
Obviously, wind energy is a really important part to future strategies to offset greenhouse gas emissions, but as with every other type of energy source, it's not entirely environmentally neutral.
Let's dive deeper. Dr. Lawson's research found that wind turbines kill 234,000 birds a year. That sounds like a lot of birds. Some bird species, like eagles and hawks, are impacted more than other kinds of birds. But it turns out the overall number of dead birds is lower compared to other things that kill birds. Communication towers, 6.6 million, 200 million by cars. Building windows kill 600 million birds.
Yep.
And don't get me started on cats. They kill 2.4 billion birds. Our wind turbines
really natural.
anymore instead of the
Yeah.
On a per unit basis and collectively, we do estimate that all buildings and other buildings are causing a greater amount of bird collision mortality.
As wind power steadily grows to offset the effects of climate change, the U.S. Fish and Wildlife Service estimates 1.4 million birds will be killed by wind turbines. What happens then?
The thing that researchers and ecologists and decision makers have to keep appraised of the situation as we continue to develop out various forms of energy into the future.
So are wind turbines killing a staggering number of birds? The answer is no. Clearly, birds are dying, but at a level that generally represents a low risk to their overall survival. And the risk certainly doesn't compare to the way birds are killed by windows or cats. Got something you want to verify? Send me an email.
When you're
Anybody ever seen a bird fly into a window? Okay, yeah, that's kind of a thing. So I see it a lot because my birds are obviously attracted because I have feeders and they will slap into the window. And if you go out and look, if you ever gone out and looked at the bird that hit to see if it's alive, it tends to look like this. Like they are completely stunned. Like they're in a biological state of shock, a physiological shock. And if you pick them up, they'll lay there like, usually mouths are wide open, their eyes are huge. Yeah. What you think, Eunice? Hold on. Eunice is talking. Uh-huh.
A bird died because it hit our window super hard.
Oh, goodness. Yeah. Ah, that sounds bad.
I got a long time ago. We had a bird nest, but then two of the birds, my dad left it open, two of the birds flew out. We just kept it flew out and then we fell. Okay? I'm talking like this.
Okay, wait a minute now. Goodness. So hold on. So I'll tell you this. So because my window is so big, when the sun is right, it reflects the trees. And that's what they see. It's like a mirror. Now, these guys can, like I said, slap into the mirrors and whatnot. I mean, slap into the window like it's a mirror and fall. But I have an oriole. I have a male oriole who, when it's mating season, becomes very, very territorial of other male orioles who don't exist here. He seems to be the only one, except for the male oriole he sees in the window. And he beats my windows to death. I have video of this nerd. I'll have to put it in the email, whatever. I have video of this nerd. He's standing. First, I thought he was just unable to land on a feeder because I had a feeder here at this window, like one of those suction ones. And I thought maybe he was just unable to figure it out. It took me a little while to figure out. No, he's trying to kill himself because he thinks he's a bag. He will fly up and down. So I thought, okay, well, you know what? You know what to fix this? I'll just open the window. No, he came in twice. I had to catch him twice. He was up there, get him off twice. So yes, Alex.
The second biggest risk to birds is tall buildings. It's just like, it just amazes me that they're still alive. If they're that stupid, that it's like tall buildings are your second largest.
They don't even
risk.
see the building. They
Like,
just see
you can
reflections.
fly.
Yep.
It's not even because they're falling. No, it's because they can't see.
So let's look at how Earth's energy kind of all works together, all these different pieces. You know, we love some TED Ed. TED Ed's always great, right? Yeah.
Energy is all around us, a physical quantity that follows precise natural laws. Our universe has a finite amount of it. It's neither created nor destroyed, but can take different forms, such as kinetic and potential energy, with different properties and formulas to remember. For instance, an LED desk lamp's 6-watt bulb transfers 6 joules of light energy per second. But let's jump back up into space to look at our planet, its systems, and their energy flow. Earth's physical systems include the atmosphere, hydrosphere, lithosphere, and biosphere. Energy moves in and out of these systems, and during any energy transfer between them, some is lost to the surroundings as heat, light, sound, vibration, or movement. Our planet's energy comes from internal and external sources. Geothermal energy from radioactive isotopes and rotational energy from the spinning of the Earth are internal sources of energy, while the sun is the major external source, driving certain systems like our weather and climate. Sunlight warms the surface and atmosphere in varying amounts, and this causes convection, producing winds and influencing ocean currents. Infrared radiation, radiating out from the warmed surface of the Earth, gets trapped by greenhouse gases and further affects the energy flow. The sun is also the major source of energy for organisms. Plants, algae, and cyanobacteria use sunlight to produce organic matter from carbon dioxide and water, powering the biosphere's food chains. We release this food energy using chemical reactions like combustion and respiration. At each level in a food chain, some energy is stored in newly made chemical structures, but most is lost to the surroundings as heat, like your body heat, released by your digestion of food. Now, as plants are eaten by primary consumers, only about 10% of their total energy is passed on to the next level. Since energy can only flow in one direction in a food chain, from producers on to consumers and decomposers, an organism that eats lower on the food chain is more efficient than one higher up. So eating producers is the most efficient level at which an animal can get its energy. But without continual input of energy to those producers, mostly from sunlight, life on Earth as we know it would cease to exist. We humans, of course, spend our energy doing a lot of things besides eating. We travel, we build, we power all sorts of technology. To do all this, we use sources like fossil fuel, coal, oil, and natural gas, which contain energy that plants captured from sunlight long ago and stored in the form of carbon. When we burn fossil fuels in power plants, we release this stored energy to generate electricity. To generate electricity, heat from burning fossil fuels is used to power turbines that rotate magnets, which in turn create magnetic field changes relative to a coil of wire, causing electrons to to be induced to flow in the wire. Modern civilization depends on our ability to keep powering that flow of electrons. Fortunately, we aren't limited to burning non-renewable fossil fuels to generate electricity. Electrons can also be induced to flow by direct interaction with light particles, which is how a solar cell operates. Other renewable energy sources, such as wind, water, geothermal, and biofuels, can also be used to generate electricity. Global demand for energy is increasing, but the planet has limited energy resources to access through a complex energy infrastructure. As populations rise alongside rates of industrialization and development, our energy decisions grow more and more important. Access to energy impacts health, education, political power, and socioeconomic status. If we improve our energy efficiency, we can use our natural resources more responsibly and improve quality of life for everyone.
Yay, Ted. All right, so let's look real quick at some conservation here. So we're gonna wrap up. Yes.
It does hurt me a little bit that it said stored as carbon, but it is stored alongside the carbon. It's not stored in the form of carbon. It's stored in the form of molecules that contain carbon. If it was stored as carbon, like could turned in from energy into carbon, then there would be like there would be a lot less carbon stored. It is stored.
I think you're making a very deep point there.
It is
Yeah.
stored in the molecular bond
Within the carbon. Correct.
Containing
Yes.
molecules.
Yes. All right. So very clearing
It
the
is
point.
not
All right,
stored-
so let's look here real quick at world consumption. Now, this is a 2013 chart. There's probably a better one somewhere that I just didn't happen upon. So this is the world consumption in 2013. So we're looking at how many years ago?
10.
Okay, very good. That was hard math, right? All right, so most here was our fossil fuel with petroleum, coal, and natural gas, with 19% renewable and 2.6% nuclear. Of the renewable, this little chunk they've taken out and put it here, most of it was traditional biomass. So this is like, making your log fire, basically. And then we had our bioheat, ethanol, biodiesel, biopower, hydropower, which you would think there would be more hydropower. I mean, this is a decent amount, 3.8, but I would think there would be more than 3.8. Then wind, solar, different kinds of solar, passive, active, geothermal electricity, and then ocean power gets almost no use at all. Okay, so here's 2010 energy use. So again, we've got petroleum refining, other, metal, paper, and this is energy use by type of industry. So our petroleum refining uses most of the energy. Guys, so we have mostly fossil fuels used for energy, and most of the energy we produced is used for refining those fossil fuels, essentially. So it takes energy to give energy to people. And then you got chemical, metal, paper. That's interesting. We're using less and less paper these days, but paper manufacturing. Anybody ever been through a town that has a paper mill before? Oh, tires are fun too. What's the one that we pass through whenever we go to visit our people in Virginia? Do you know the name of the town? Franklin. Franklin, Virginia is a paper mill town. You can see it.
Virginia.
It's the smoke it produces is kind of a yellow, and it smells like you would not believe. And these people live in this town. They live with it. It's unreal. I don't get it. So the amount of work produced compared to the amount of energy used. What's this? Do we know what this is? Liam. There you go, efficiency. So now you're looking for efficiency. So it's the amount of work produced compared to the amount used. So to be efficient, you would want, what kind of relationship do you want between what's used and what's produced? What do you think, Bailey? Yeah, you want to use as much as you produce, right? You don't want to like, quote unquote, waste it. So we have improving efficiency in industry. In some ways that's done, that's just a transportation, that picture cut it off, but improving efficiency in transportation, commuting efficiently, fuel efficient automobiles. Now, we talked about efficiency in automobiles last week with electric automobiles. What is one way that states, communities, cities can improve energy efficiency with commuting in particular? Anybody have an idea? Bailey? Buses, trains, MARTA, subways. Anybody have a different, Bike pass is good. Anybody else have one? Oh, Piper says walking. How about you, Alex?
Or you cannot have, nothing can be 100% energy efficient because of thermodynamics.
Yes, you can't. That's not possible.
What else
Yeah.
was I going to say?
No. Yeah. Buses. Yeah, that's some Bailey.
I wanted to ask.
Yes.
If the smoke influences the color of clouds in Franklin.
Yes, I guess. I don't know. The whole town's a cloud.
Does it look like
Yeah.
a colored cloud?
Caitlin says horses. Okay, let me ask you this. You ever been on the highway and seen a road with a big old diamond painted on the lane? What's that? What is that, Liam? HOV. What's HOV promote?
2+ people.
Yeah, 2 or more people in a car. All right. So the whole reason for that is, hey, you get to ride in this lane if you've got 2 or more people in your car. Most people commute to work alone, Parker. Most people commute to work alone. So if you find a carpool buddy that can go to work with you, then you get the special privilege of riding in the lane with less traffic and you get there faster. And that's how we promote HOV. Yes, Bailey. Shh, wait a second. I can't hear you. Hold on. Wait a minute. Say it again. Yep. Or they'll put a blow up dummy or a doll or a mannequin.
That's just too much work.
And then there's the pregnant ladies that ride it because, you know, we got 2 people in the car.
Now that's just smart.
Yeah, tint your windows. All right, so Milo. Yep. Wait a minute. I don't think the person for ambulance will take that. That's a great question. Very good question. All right, so let's hold on. Okay, let's move on to this next one then. Okay, so getting more for less. This is when we're going to harness our waste, which is often thermal energy. Whoops, I didn't mean to click that. So cogeneration. You with me, guys? Cogeneration is the simultaneous production of 2 usable forms of energy. So here's an example. You're sitting here and you have your crop. So where do we start this? Let's start this thing. Okay, let's start it here. So you've got crop nutrient production. So they're taking plants, right? And they're producing this waste heat, which goes into a boiler. And then the boiler produces steam. And then there's a steam generator that can go to a power grid. It can go to a mine. It can go to processing plants and then back around. Anybody ever lived anywhere with a boiler system? Radiators. Nope. So when I was in college, we had a central boiler for the campus. We had a big old boiler. And it fed nice hot water all over the campus. It fed it, yes, to the showers and whatnot. But if you were in one of the old antebellum buildings, and there are quite a few, and then you have a radiator in your room, and your room or whatever, your dorm room is heated by steam heat that came through the radiator. Radiators are great. And there's also baseboard heating that's been done that way in the past. Radiators give you a lot of heat, and it's a moist heat. It's not that dry, make your nose dry heat that most of our heaters have. Yes.
I got a question about carpooling.
Yeah.
Kidnap victims count for carpooling.
Yes, they do.
Of course. I mean,
All right. So back on focus. We're going to refocus. So no. All right. So we're going to refocus here. All right. Global management of Earth's natural resources to meet current and future needs is called what, Yusuf? Sustainable energy. Okay. This is an essential concept, guys, because it doesn't matter, you know, we're going to start these labs, right? These global warming labs. All right. Again, these back and forth documentary things. And you're going to hear a whole lot about how sustainable something is. No matter how sustainable you think fossil fuels are, they have to be sustainable enough. Now, the question is, what is sustainable enough, right? Like, when are we going to run out of fossil fuels? Are we going to, I mean, in any kind of foreseeable future, will we? Eventually, yeah, because they're not renewable, right? Eventually, there won't be any more, because if we use them all up, then they're gone. The what?
It's a, like,
Yeah.
yeah.
So We will eventually run out of fossil fuels. The question is, are we going to run out of fossil fuels before we have technology to make other forms of energy more accessible and more practical? Are we going to, will it, wait a minute. Will it not matter because we will have flooded ourselves to death because all the oceans and ocean sea levels are going to rise and all the glaciers are going to melt and everything else because we've burned fossil fuels and now we've heated up the planet? Is that going to be the problem? A new ocean? Oh, yikes. So, yeah, did we hear that? Caitlin?
If, Alex's plan to clean up oil spills gets out,
Mm-hmm.
then we won't have rising sea levels.
This is true. This is accurate. Accurate. All right, now, before we wrap up, I want to tell you guys about something that's completely, it's separate and really it sort of is like next unit, but I still think it's important to bring it up now before we get to next unit because you might miss something. So next unit, when we talk about stars, we'll talk about how stars die. And does anybody know what it's called when the star goes kaboom?
Supernova.
Supernova. Okay, so the brightest, one of the stars that's closest to Earth that has been near that point is one that has a name that people pronounce different ways, but do you know? Not that one. Do you know?
I don't think it's Alpha Centauri.
No. Okay, so the one we're talking, do you know, Eunice?
Is it the sun?
No, not the sun. Thank goodness. The sun's still good.
Know where you're logic.
We're happy that the sun is not going to die anytime soon. So the one I'm talking about is, listen, hey, I don't want to talk over people. The one I'm talking about is called Betelgeuse. Sometimes people announce it Betelgeuse. I've looked it up because I always heard it was Betelgeuse, and then I've seen a whole thing. It basically goes back to like the whole Latin root and how you pronounce what part of the Latin root, blah, blah, blah. So most people are calling it Betelgeuse, but it's Betelgeuse. Okay. Now this is a big bright star and it is currently a red giant. Shh, we're listening. It started to do some minor exploding in October of this year. And then there were other incidents within the last week or two where it's starting to pop off. Like there's what look like solar flare kind of things, but they're huge and they're coming off this star and they're popping off. That star is absolutely 100% going to supernova. The question is when. It could be literally tomorrow. It could be 100 years from now. It could be 1,000,000 years from now, but it is very close. And we know it's close. And this is the first star that has been this close to us physically, that is this close to going supernova, that we are observing with the technology we have now. So it's going to be, hold on guys, wait a minute. It's going to be a big deal when it does go. So NASA has coverage on it. There are 1 million YouTubes. And if you look them out, they all say something like 4 hours ago, supernova, it's finally happening. And it's like 4 days old. So it's not 4 hours ago or whatever. So don't get overly excited about them. Hang on, sit, wait. But you're going to want to look, keep your eye on the news where that's concerned, because it could happen tonight, tomorrow, whenever. And we should be able to see it to some degree from what I hear, what I have read. So Alex, questions?
How is that going to affect like electrical grids and such? Because like solar flares could potentially knock out entire grids.
So it is like, I believe 600, almost 600 million light years away.
Oh, so it's already gone boom. We just can't see it yet.
That may be the case, yes. So we don't think it's going to cause any issues for us. They don't believe it's going to cause any sort of impact on Earth, but we still should be able to observe and research it. What do you want, Eunice? What you think?
Like how much years? Light years?
Oh, so it's not years. It's a distance. Yeah, it's like how long it takes for light.
70,000.
You know the number. I can't keep numbers in my head.
A
So
light year is the distance that light travels in
in a year. How far will light? Because light travels in two different ways. Light travels as what? Do we know? Who can tell me one? Wait, okay, waves and particles. Correct. Light can travel as waves and particles, huh?
I think it's like both at once.
Yeah, it is. It is both at once.
Light is strange.
Light is weird. Yeah, it doesn't act like most other things. Use it.
So maybe
Shh, guys in the back. Hang on.
far away, you're seeing what it looked like a million years, 6 million.
Yes.
So
Yes, that's entirely could be the case. So yeah.
problem about eating there.
Yeah, so anyway, if you're interested in that sort of thing, keep your eye on it. I'm trying to keep up with it. There's news relatively frequently because people are all over it right now because it's a really big deal. It's super cool. Like, woo! Yeah, Beetlejuice. If you've never seen the movie Beetlejuice, yeah, Beetlejuice. Yeah, they took that name from the name of the star. So anyway, it's part of Orion. It's part of the Orion constellation. I don't think it's the belt. I think it's where the sword is located. Wait a minute. Sit. Don't throw pillows. I haven't excused anybody yet. Whoop. All right. So, Alex, yo. All right. So, guys, here are your answers. You're going to want to go home and look those up. Check your work. Next week, somebody who has their binder. What's your lab? Hang on. Somebody looking with the binder. What's the lab? Hang on. Jack's got his binder and he's actually looking.
26.
Yep. What is it? I handed it to you today. Yeah, there you go. So what is that? What are we starting next week? All right. Now, we are starting the lab next week by watching the video. All right. Now, what we will probably do to make what we will do to make best use of our time, because this is that one's kind of short. The first one that we're going to watch, which is the Inconvenient Sequel. The two that follow it are a little longer, and there's two. So what we'll do next week is we will start immediately at 10:45, because that's when class starts, right? 10:45. We will start with the lesson first. We will go through the lesson, and as soon as it's done, we'll start the lab, which will make best use of our time. Because if our lesson doesn't take the full hour and a half, a lab's an hour and 15, we can add time to that, right? Okay, wherever we leave off, we'll start over the next week. If you have your lab in your hand, and everybody does except Sky, you can get it online. You want to start answering the questions that you can't answer without watching. Okay, questions before we go. Alex.
Oh, I can't remember what my hand is up.
Oh, that's about right. Anyone else have a question about next week or about today's lesson? We're good. Okay, so, oh, wait, Eunice, yes.
When is the
End of the year. Anybody know that? Who's got their, huh? There you go. Yeah, so our last lesson is May 9, and then we have class the 14th, and that's going to be our exams. Yeah, I talked to your mom about that earlier. We're going to work that out. No worries. Okay. Eunice, this is your little cubby of change. Give this to you right here. And then y'all can bring, here you go. Here's the little cubby. Y'all have at it. So you can take those up front. Here's a little cup to put your candy in. Meet. You can put your candy in by the front door. But he did. He spoke up. Yes, he did. He sure did, didn't you? Forward. Okay. Here we go. Your shenanigans. Okay, so what is it you guys are doing?
But because of the whole, we can make up some like
Yeah.
stuff.
Yeah.
We're gonna take that a little far.
Of course you are.
I know, I'm just gonna hand them out.
All right.
Yeah, 4 minutes.
Oh, well, you had two.
I had two.
Yeah, there's going to be, we're just gonna make
Could be
up
baking papers.
like travel to the that is not actually gonna be part of the jam.
Yeah.
Just for conditions.
There's gonna be a real estate market, it's booming, only $3.2 million. Dave, do you wanna buy a house?
Because we actually transport materials, everything.
Very expensive.
We're
Cole,
gonna-
what did you do your travel project on for Earth Science? Yeah, but just because you wanted to call it Uranus to talk about all the things that happened on Uranus.
And then we're gonna have various, if we have time,
We're
there's
gonna
gonna
have
be a bunch
fun, we're
of.
gonna be dressed up like guys in their twenties who've been divorced 30 times, 30s. We're gonna have like polos and khaki shorts, and
Yeah.
we're going full in character. People are gonna remember.
No.
You're going to keep those down.
No, that's right.
Okay, I'll work and do this.
So that's where he spends the morning in his training in. And once everybody is in, then I let him out. Because he's fine when we were here, but he does not like. I just remember my dad, he barks at everybody when they come. That's right, I don't know. Yeah, I got a well, when it goes wrong, everything on me is like the fireplace, the TV, everything. Hey, that smart clock. Oh, that's.
Right.
You know why that? And
Hello.
I did not know I had Andreas at 2. Oh, that's news to me. Okay. Yeah, up here.